So in this problem, we have lots of information. So just read the question first. Find the constants A, B, and C, and D. Now, since we know what we're looking for, now go back into the paragraph and look at what we need. So in physics, it's always a good idea just to draw a picture so you can wrap your head around it. So it says a rocket is launched from an angle at the top of a building at height 42.2 meters. Okay, so the unit's meters, we got that. We have a little building, a little rocket. The rocket's not pointed straight up because it says there's an angle. Now I just rewrote everything they gave me, all the information. So they gave us x, this formula for x, which just means that it's the x, so that means it's the x-axis. Since this is the position time graph, this will be the position time graph of where the rocket is on the x-axis. So this is on the x-axis, this is the y-axis of the position of where it is. And these are the velocity of where it is. After a certain time, what is the velocity at that time? And what is the acceleration at the time? Here they give us, after 1.1 seconds, they actually give us a specific acceleration, meaning that they say that and this just means that I and J is the x direction and the y direction. That's how they write it in physics. So it's usually I hat and J hat. All that means is it's just the I is the x direction, J is y direction. And here they give you a specific that at 1.1 seconds, the acceleration is going to be 5.9 meters per second, that's units, in the x direction, and 4.95 meters per second in the y direction. So we have all that information, but now how do we start? Well, we can just start plugging and chugging and see what works. So what I can do now is the last piece of information, which is this. The origin is at the base of the tower. So now we know where we can draw this on an actual graph. So we have our graph. This is the origin, and it says that it's going to be up 42.2 meters. So this is on the y-axis. But what does this tell us? If we imagine that the entire building was on this y-axis, this means on this y-axis, there's no x, meaning at time equals 0, the entire position is only y, and there's no x. This will come in handy. So now all I do is I just try out different things. So I'm going to write the x one, and we're given that the time here is 1.1, so I'm just going to try that. And so I plug it in, I plug in 1.1 into the x formula, and I get a plus 1.23b. And I do the same thing for y. I plug in 1.1, and I get c plus 1.368d. And I didn't round it here because I didn't want rounding error. So this information could be helpful, but we don't know. We still need to find the constants, and I don't see how. I can't set these equal to each other because that wouldn't work. That wouldn't mean anything. So we can't do that. So we have to do something different. So we already plugged in 1.1. The only other time we know is 0, meaning because we don't know the flight path of this rocket. But we know at 0 it was fired from this building. So what does that mean? It means that at this building, at time equals 0, the y position was 42.2. We can use that. So all I did here is, since this doesn't work, I just tried something different, and so I did the y-axis. I said at d0, okay, it'll equal c. So now we only have one constant. That's good, because at time equals 0, the entire y-axis is on 42.2. So I can set that equals a c, and I got one of the constants, and that's 42.2 meters. Make sure everything's right. Like, you look in the beginning, middle, and end, meaning you look at the beginning, make sure it's positive or negative. In the middle, check for sig figs, which is 3, that's right. And the end, which is the units, and that's meters. So that's good. So now we found 1. So now the other 3. So since we know that the entire y-axis, the rocket will be at this spot, meaning there's no x. That means at time equals 0, this will be 0. So all I'm going to do is I'm going to do that. I'm going to plug in time equals 0. I get a, because this will all go to 0. I'll get a remaining, and then I'm going to set a equal to 0, because the position at time equals 0 for the x direction is 0. Because here, as you can see, if this is where the rocket is, that means that there's nothing on the x-axis. So therefore, I can set it to 0, and therefore I get 0 meters. Once again, you make sure that it's not negative or positive. You check the sig figs. Since it's 0, it doesn't really need sig figs. And finally, the units, because since it's position, it's meters. So now we keep going on. Because now we found 2, but we still need the other 2. So for physics, you just try anything you have. You try everything and anything. Because sometimes you won't get it the first try, and that's okay. You just keep trying different things until you get the answer. So here, what I tried velocity, because they gave us that information over here. They gave us velocity. So all I'm going to do is the same thing. The only 2 pieces of information I have is when it starts, so at time equals 0, and at time 1.11. So I'm going to go back. So here, all I did was I just plugged in 0 and saw what I got. So here, it wasn't terribly useful. It just showed me that when it starts, it has 0 meters per second. So that means that when it was beginning, it was fired from rest. I mean, it could be useful in the future, but right now it can't really help me. So I'm going to keep going. So the other piece of information I have is 1.11. I plug that in, and it gives me the velocity here. So this velocity answer, it still can't really help me, because it's not like I can set it equal to the position, because that's 2 different things. I can't just plug in the velocity for here, because this is not velocity, it's position. So once again, I tried that and it didn't really work, and that's okay. At least it could be useful in the future. So let's just keep trying different things. So in our information, we already tried this, and we got at least 2 constants. We tried this one, velocity. So now we have 2 information left, 2 pieces of information left. Now we can try those. So once again, the only 2 other pieces of information I have is 1.1 and then 0, time equals 0. So let's just keep trying. So here's acceleration, here's the formula, and all I did here was I wrote down that information and stopped and thought about what this actually meant. So I had just means that this is the acceleration, because that's the unit. It's the acceleration in the x direction. I means x, in the x-axis, x direction. So this is 5.90 meters per second, because it's acceleration, in the x direction. And this is the same, 4.95 meters per second in the y direction. So how can that help us? Because we had another equation, which is 2b I hat plus 6dt j hat. And remember, these are just units, meaning like when you do calculations, they don't affect your answer. Just the same as it's just telling you direction. It's like having north, right? You can't multiply north. So that's all it means. It's just a unit. So all I'm going to do here is look at the units, right? So since both of these are in the x direction, what does that mean? I can set them equal to each other, because since there's no time, I don't even have to worry about that. It's just the constant. So all I do here is put 5.90 is equal to 2b. And then I divide both sides by 2, and I get b equals 2.95 meters per second. All I did was I saw that both of these are in the x direction, which is the I hat direction, same thing. And then since there's no time, I don't even have to worry about that. And since these are equal, since they're both the same unit, both acceleration, I can set them equal to each other and get b. So now we have one more constant to find, and that's d. So here, if you remember from the problem, I can actually show it. In the problem, it says that this equation is given by 1.1 seconds. When this is the acceleration after 1.1 seconds, this is the x and y direction of that acceleration. So going back to that problem, all I do here is I see that since this is both, these should be equal to each other, or I can set them equal to each other, because this is at 1.1 seconds. All I have to do here is make the time 1.1 seconds, and I can set these equal to each other. So that's what I do. I put 4.95 equals 6 dt j hat direction. I plug in the time, which is the same as this, 1.1. I get 6.66 d, the constant, and then I divide by 6.6 on each side. I get 0.743 j hat equals d. So make sure you have everything you need. You check the front of it. There's nothing. It's not positive or negative. Because since this was positive, it'd still be positive. Here you check the middle. So that's going to be the sig figs. So the sig figs will be 3 because everything before it was 3. And finally the units. Units are meters per second squared because that's the units of acceleration, and that's the formula we used. So I hope that helped, and thanks for watching.